Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. Today we're going to be looking at paper 3 from June 2019. Now, with the new specification being new, grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome along to another AQA GCSE Mathematics past paper walkthrough. Today we're going to be looking at paper 3 from June 2019. This is the calculator paper. Let's get busy. Question 1. Work out £1.50 as a fraction of 60p. Circle your answer. Now, just take note of the wording. £1.50 comes first, so we're putting £1.50 as the numerator. £1.50 is the same thing as 150 pence, isn't it? So, as a fraction, I'm going to write 150 pence over 60 pence if I want to write £1.50 as a fraction of 60p. Alright, I can cancel off those zeros straight away, and I've got 15 over 6. Any other common divisors? Well, you can divide both by 3, can't you? So, dividing both by 3, I'm going to be left with 5 over 2. Just that one there, isn't it? Question 2. For a biased dice, probability of 6 is equal to 3 over 5. Now, bias in probability means that it's not fair, so that means the number 6 is coming up more often than it should. On a fair dice, you'd expect it to come out one try in every 6, so 1/6. So this biased dice is a lot more likely to come up as a 6, isn't it? 3/5, that's over a half. So circle the probability of 2 6s when the dice is rolled twice. Okay, so the probability then of 6 followed by a 6, that's going to be the probability of a 6 times the probability of a 6. And in probability means multiply, or is add and is multiply. It's just a kind of rule of thumb that you can use. So the probability of 6 and 6 is going to be probability of 6 multiplied by the probability of 6. So basically we're just multiplying 3 and 5 together. Sorry, 3/5 and 3/5 together. So 3 times 3 is 9, 5 times 5 is 25. So it's going to be that one there, 9/25. Question 3. Circle the lowest common multiple, LCM, of 5, 15 and 25. Okay, there's a way of doing this using prime factor decomposition, but I think we'll find it quite quickly just by finding multiples of 15 and 25. Don't think we have to worry too much about 5, because 5 is, well, it's a factor of 15 and 25 anyway, isn't it? So all the multiples of 15 are also multiples of 5, so I'm not going to even bother with that one. Let's start with 15. 15, 30, 45, what's next? 60, 75. Okay, and 25 goes 25, 50, 75. Okay, so I found one already. Look, it's there and there. And because 5 is a factor of 15, then 5 is also a, well, it's only 5 is also a multiple of 5. So it's that one there. Circle the two roots of x minus 5, x plus 3 is equal to 0. Now, if I was wanting to imagine the graph of y equals x minus 5, x plus 3, it's a quadratic, isn't it? So it would have a parabola shape like this, and it would cross the x-axis in 0, 1, or 2 places. Here it's going to cut in 2 places. If you remember rightly, the equation of the x-axis is y is equal to 0. So basically, if you're asking when x minus 5x plus 3 is equal to 0, you're asking where these 2 points are. Okay, what value of x you're going to get there and there. You're going to get those when one or other of these brackets is 0. So either x is 5 or x is minus 3. Okay, circle the two roots, so minus 3, 5. Question 5. On the grid, draw an enlargement of the triangle with scale factor of 1/2. Okay, now there's no center of enlargement given, so we can just draw this enlargement anywhere on the grid. We're not dictated by the center of enlargement. So what do you do to draw an enlargement? Well, you need to measure these. So that length there is 4 squares, isn't it? Let's take the measurement of the tip above the base. That's probably the easiest one to measure. That is 1, 2, 3, 4, 5, 6 units up. So if I'm going to multiply those distances by a scale factor of 1/2, 4 times 1/2 is 2. So I'm going to get a line which is 2 units along rather than 4. 2 units. And 6 times 1/2 is 3. So the tip of my triangle is going to be 3 units above. So let me just put that in as a dotted line. 3 units is my center of my triangle, the perpendicular height of my triangle, I should say. Okay, now let's just draw the 2 sides on. Okay, so only in the crazy world of mathematics can you get an enlargement that is smaller than the original shape. But there we go. Scale factor of 1/2 is going to end up smaller. Question 6. To the nearest pound, John has £9. To the nearest 50p, Ellie has £6.50. Work out the maximum possible amount of money. There's a couple of clues in here that this is not a straightforward question, actually a limits of accuracy question. This and this to the nearest should indicate that it's going to be a limits of accuracy question, and also where you're being asked about maximum possible or minimum least possible amounts. You're likely to be in a limits of accuracy question. Right, so how do you approach these? Well, I always draw a scale and I mark on the number I'm given, 9. So it's to the nearest pound, so I'm rounded to nearest pound. So I'm going to use that scale to go £1 up and £1 down. And the values that round to 9 then are going to be the values that are halfway between 8 and 9 up to halfway between 9 and 10. They're all the ones that round to £9, aren't they? Okay, so the boundary of that is going to be £8.50 at the lower end and £9.50 at the upper end. And obviously £9.50 technically rounds up, but it's still the boundary and it's still the value we use in these calculations. Okay, so £9.50 there. So to the nearest 50p, Ellie has £6.50. So again, I'm going to do a similar thing for Ellie. So mark the number I'm given, £6.50, and I'm going up in 50p's here. So the next one up is £7, and the one below is £6. So halfway between the two is going to be there, isn't it? That's £6.25, and halfway between £6.50 and 7 is £6.75. So all the values in between round to £6.50. Okay, now we want the maximum possible value. So the maximum possible means in this case, if I'm going to add these two together to get their total, aren't I? So I'm going to be adding the upper bounds of these things together. Now, normally in these sort of limits of accuracy questions, I would advise you just to use these maximum values in your calculation. So you should use 9.5 and 6.75 in your calculation when you're finding maximums. But in this case, money, pounds and pence, is a discrete amount. It's not a continuous amount. So actually, the highest amount possible for John is not going to be £9.50, because I would have to round up in that case. It's going to be £9.49. So for this particular case, because it is discrete data, I'm going to eschew my normal advice of going for the maximum value of £9.50 and go for one less, £9.49. And the same for Ellie's £6.75 upper limit. In this case, I would advise using £6.74 instead, because money is discrete and not continuous. Okay, so there we go. So £9.49 plus £6.74. Calculator, what is £9.49 plus £6.74, please? It's £16.23. £16.23. Question 7. Two solids J and K have the same density. Complete the table. Include units in your answers. Now, do you know the formula for density? Density is equal to mass over volume. Okay, that's the basic formula. So if I know the mass and the volume, I can divide one by the other to find density. So for J, I've been given the mass and the volume, so I can use it to calculate density. 48 divided by 8. 48 divided by 8 is 6. 6 what? It says I need to include units in my answers. So I'm dividing grams by centimeters cubed. So compound units tells me that's grams per centimeter cubed. Or you could, if you want to be smart, write grams per power of minus 3. So grams to centimeters to the minus 3. Okay, because you know that a negative index means the reciprocal of. Okay, so it's the same thing as dividing. But anyway, I'm just going to write with a slash. Right, so then we're told that they have the same density, so I can then copy this value over into the other half of the table. So this is also going to be 6 grams per cubic centimeter. And I'm going to need to work backwards to find volume. So I've got density up here and volume down here. So if I just switch those around by cross multiplying, I'm going to get volume equals mass divided by density, then aren't I? So here I'm going to be, I've got a mass of 78 and I want to divide it by a density of 6. What's that then? 78 divided by 6, 13. Okay, then remember I need to include units, so in this case it's centimeters cubed. Okay. Question 8. Rearrange y is equal to 3x minus 2 to make x a subject. Now, when we're rearranging formula, we're kind of unwinding our expression, aren't we? We're moving everything from one side over to the other side of the equal sign. Now, if you knew the value of x and you wanted to evaluate this expression, so if I knew like x was 3, for instance, I'd multiply it by 3 and I'd subtract 2. So I'd do the multiplication first, and then I do the subtraction, because the rules of BIDMAS tell me that: brackets, indices, division and multiplication, and then addition, subtraction. Now, when you're rearranging formula, you kind of unwind these things, so you have to kind of work through BIDMAS backwards. So if you're ever wondering which one to move first, you go through the list in the opposite order you would do if you were evaluating the expression. So here, like I say, I've got y equals 3x minus 2. If I knew x, I'd multiply it by 3 and then I'd subtract 2. So working through backwards through that, I'm going to add 2 first to both sides. So I'm going to get y plus 2 is equal to 3x. And then I'm going to do the opposite of multiplying, which is dividing. So we divide both sides by 3. That's going to cancel with that, and it's going to leave me with x is equal to y plus 2 all over 3. Okay, which is which one? It's that one there, look. Question 9. Towns P, Q, and R are connected by roads PQ, PR, QR. PR is 10 kilometers longer than PQ. QR is twice as long as PR. The total length of the three roads is 170 kilometers. All right, now this is not drawn accurately, so it's not about measuring the distances and using those. I'm going to have to work it out. Okay, I'm going to add these roads in first. They're not drawn, are they? So PQ is the road between P and Q. So let's just draw that in. PR is the road between P and R. So let's draw that in. Oops. Okay, now I'm going to assume that that doesn't actually drive into the C. And then QR is this road here then. They're not necessarily straight lines actually. It doesn't say they're straight. Okay, so we are told that PR is 10 kilometers longer than PQ, but we don't know how long PQ is. Now, if we don't know anything in maths to start with, then use algebra. So let's say PQ is equal to X. So I'm going to make this one here X. Then PR is 10 kilometers longer than PQ. That makes PR X plus 10 kilometers longer than X. And we're told that QR is twice as long as PR. So PR is X plus 10. So QR is twice that. So it's 2 lots of X plus 10. Now we're told that the total length of the three roads is 170. Okay, so what we're going to do is we're going to take our three expressions, X, X plus 10, and 2x plus 10. We're going to add them together, and that should give me 170. Okay, so let's just write that down. So I've got my X, X plus 10, and 2 lots of X plus 10. And I know that that is 170. Okay, these were my three roads, and this was the total I was given in the question. Okay, so now it's a matter of just kind of collecting like terms together and then see if we can solve this for X. Okay, so let's just remove the brackets over here to start with. So that's going to give me 2x plus 20, isn't it? Okay, I've still got my 10 and my x and my other x over on this side. Right, then collecting like terms together, what have I got? I've got an x, and a 2x. That adds up to 4x. And I've got a 10 and a 20. So that adds up to 30. So I'm going to get 4x plus 30 is equal to 170. So that was all my blue ones, that was all my purple ones, and that was the one I had before. Okay, so 4x plus 30 is equal to 170. Okay, so now I've got a linear equation in X. I can go on to solve it. Let's subtract 30 from both sides to start with. Okay, again, if you're wondering about which one to move first, if you think about what I was saying in the last question about BIDMAS backwards, it's the same when you are solving these sort of equations as well. You kind of unwind them going through the opposite order that you would do if you were actually working them out. Okay, so that's going to cancel with that, and it's going to leave me with 4x is equal to 170 subtract 30 is 140. And then I'm going to divide both sides by 4. Divide by 4, divide by 4. What's that going to give me? So that's going to cancel with that, leave me with x. And then 140 divided by 4 is 35. Do it on a calculator if you're not sure, but I can do that in my head. X is 35. Right, have I answered the question? The question was, work out the length of PQ. Which is PQ? PQ is X. Oh, okay, that's easy enough. Then we have worked out the answer. It's 35. Question 10. Mia wants to borrow £6,000 and repay it with interest after 2 years. She sees two offers for loans. Now, offer 1 is compound interest for 3% per year, and offer 2 is compound interest, first year 1%, second year 5%. Mia says, I will pay back the same amount because the average of 1% and 5% is 3%. Is she correct? You must show your working. Well, any way to find out is to do it. So let's see if we can work it out. So let's have a look at offer 1 first. Offer 1. Now, we want to do £6,000. Okay. Now, when you're doing interest, I use a triangle FOM, final, original, multiply, FOM FOM. And I'll put my finger on the thing I want to find. In this case, I want to find the final. I know the original and the multiplier. So the final is the thing I want to find. The original is what I started with, 6,000. And the multiplier is, well, it's 3% per year. So if I've got 100%, I want to do a percentage increase of 3%. Then that's 100% plus 3%, which is 103%, which is 1.03 as a multiplier. Okay, so then my final amount, covering up the thing I want to find, it tells me what to do with the other two things. So my final is going to be the original times the multiplier, but because it's compound interest, I'm going to raise that multiplier to the number of years that I'm applying it to. So it's going to be 6,000 times, so it's going to be this raised to the number of years, isn't it? Okay, so it's going to be 1.03 squared. So what's that then? 6,000 times 1.03 squared comes out to be £6,365.40. 6365.40. Okay, now offer 2 I'm going to have to do in 2 steps. So final is what I want to find again. Original is 6,000, and then multiplier for the first year is 1%, isn't it? So it's 101%, which is 1.01. Okay, so then again, final equals original times multiplier, which is 6,000 times 1.01, which is what? It's just 6,060, isn't it? Okay, so that's in the end of year 1. So this is year 1. And then in year 2, my final is going to be my original, which was 6,060 now, because it's what I got from the end of year 1, times my new multiplier of 1.05, because it's 5% in the second year. So 6,060 times by 1.05. So that actually comes out to 6,363. So it actually works out a little bit cheaper. So is she correct? No, she is not correct. I think we've done everything. We've got our 2 answers, haven't we? This is the first offer 1, and this is offer 2. We found both answers, and we're saying she's not correct. I think that's fine. Question 11. Here are 2 sets of numbers A and B. The mean of set A to the mean of set B is 3 to 8. Work out the value of x. Okay, so this is going to be a several step problem. First off, we're going to have to find out what the mean of this is. Okay, and then we're going to use the ratio to find out what the mean of set B should be, and then we're going to form an equation using this information and our answer from the ratio question to form an equation in x, which I hopefully can then go on and solve. Okay, so lots of steps. That's 4 marks. So let's just do it. Okay, so let's think about the first step I said then. So finding the mean of set A. So let's do that first. For set A, mean is equal to, well, how do you find the mean? You add all the numbers up and you divide by however many numbers you've got, which is 4. So calculator, 200 plus 160 plus 104 plus 100. Don't forget, anything you type into your calculator, make sure you've written down on the paper. Divide that by 4, comes out to be 141. Okay, so the mean of set A is 141. Now we know that set A to set B is in the ratio of 3 to 8. Now we've already worked out the mean of set A is 141. What we want to know is the mean of set B. Okay, so we're going to use what's called the unitary method, which is going via 1. Okay, so it's quite simple. What we do to do the unitary method, we've got 3 things here. If we divide by 3, we'll get to one thing, and then if we take that one thing and we multiply it by 141, we'll get 141. But if we do that to one side of a ratio, got to do it to the other as well. So I'm going to divide by 3 and then times by 141. So what's that then? 8 divided by 3 times by 141. That comes out to be 376. 376. So now I know that the mean of my set B is going to be 376. So let's have a think now about set B. So to find the mean of a number, we take all the values, we add them up, and we divide by how many we've got. So we've got 5 values now: 270, 400, 480, 300, and x. So let's add those up. So 270 plus 400 plus 483 plus 300 plus x. So then to find the mean, we would divide all that by 5, wouldn't we? But we know that that already is equal to 376. Okay? So what we're going to do here, well, I'm going to add up the numbers on the top to kind of collect like terms together. So 270 plus 400 plus 483 plus 300. That comes to 1,453. So the top of my quotient there comes out to be 1453 plus x is equal to, I'm going to take this 5 that was dividing down here, I'm going to cross multiply it up there. So I'm going to times both sides by 5 basically. So what's 376? 376 times 5, that comes out to be 1,880. So 1,880. So I've got a linear equation in x now, so I can just take away 1453 from both sides, and it should leave me with x then, shouldn't it? So x is going to be equal to minus 1453. That comes out to be 427. 427. Okay, and that's my answer for x. 427. Yep, wanted to find x, found it. Question 12. A straight line has gradient 4 and passes through the point 523. Work out the equation of the line. Give your answer in the form y equals mx plus c. Okay, so we know that the equation of this line is of the form y equals mx plus c, and we're told here that the gradient is equal to 4, and that means m equals 4. So I know the equation already is of the form y is equal to 4x plus c then. So all I really need to do is find c. Now the second bit of the information tells me that my line passes through the point 523. So I can use that information. Passes through 523. So that's the x coordinate there, isn't it? And that's the y coordinate. So if we sub those into the equation, they should work because it's a point on the line. And then the only thing that I don't know there is going to be c then. So subbing those in, so 23 is equal to 4 lots of 5 plus c. What's that? Let's just multiply out those brackets. 4 times 5 is 20, isn't it? So I've got 23 is equal to 20 plus c. Let's just subtract 20 from both sides. It's going to leave me with c equals 3. So now I know all the pieces. I've got m, I've got c. I can write down the equation. It is y is equal to 4x plus 3. Question 13a. Vectors a and b are drawn on the grid. Yes, they are. And then underneath it says write down b in terms of a. Now you should be able to see from here that a is parallel to b. So they're not going in the same direction, are they? Because a is going from left to right, and where b is going the other way around by looking at the arrow, it's going from right to left. But they're in opposite directions, aren't they? So if one is positive, the other one is going to be negative then. So write b in terms of a, but you can also see that from one end of the line to the other, it's like 3 along and 2 up. So if I did that here, look, 3 along, 2 up, 3 along, 2 up. You can see that the vector a fits into the magnitude of vector b twice. So b is twice as long as in the opposite direction to a, it's going to be negative 2 lots of a then, isn't it? So b is minus 2 lots of vector a. Okay? Now draw an a with a little hat like that because it's a vector. And I can't draw in bold. I don't know if you've seen that these are written in bold. Now I can't write in bold, so I put a little line on the top to show it's a vector. Question 13. B. Vectors c and d are drawn on the grid. Yes, they are. On the grid above, draw the vector representing c minus d. Okay, c minus d means going along vector c and going against vector d. Okay, so I'm going to start. So c is going from right to left and d is going from left to right, but we want to do a minus d, so it's the other way around. So I need to I'm going to start on the right hand side of my paper, otherwise I'm not going to fit it all in. So let's start at this point here. Vector c goes 1 to the left and 2 up. So it's going to take me from there to there. Okay, now d is normally 1, 2, 3, 4, 5, 6, 7 units to the right. But if I want to do minus d, I want to go the opposite way. So I'm going to go 7 to the left. 1, 2, 3, 4, 5, 6, 7. Okay, so that's vector c, and that's vector d. So from there to there then is vector c minus d. Okay, so actually we want to draw a vector representing c minus d. Now that's the resultant vector of those two. Okay, so if I was going directly from c, my starting point, to d, my end point, my resultant vector then is this. Good, let me draw a pen. Okay, there we go. So from here to here, going straight, now that is the vector c minus d. Question 14. For class X, the number of boys to the number of girls is 7 to 8. And for class Y, the ratio of the number of boys to the number of girls is 3 to 4. Which statement must be true? Class X has more boys than Y. Class X has twice as many girls as class Y. Class X has greater proportion of boys than class Y. Class X has the same proportion of boys as class Y. Okay, interesting. So, number of girls to number of boys to number of girls for class X, 7 to 8 and 3 to 4. Now, they're not equal to each other, are they? You can't just double up class Y and get class X. So, they are not in the same proportion. So, I know it's not going to be that last one. That one's not a possibility. Must be true, so must always be the case. Class X has twice as many girls as class Y. Well, that is not always necessarily the case, because it depends. We've got the ratios here, we haven't got the actual sizes of these classes, so we're not going to be able to tell that one. Class X has more boys than Class Y. Now again, for the same reason, we can't tell that one. So the only one that we can be sure about, I suppose, is this one that's left over. Class X has a greater proportion of boys than Class Y. Yes, that is true. If I doubled up 3 to 4, I would get 6 to 8. So I've got 6 boys to every 8 girls in Class Y, and I've got 7 boys to every 8 girls in Class X. So proportionately, there are more boys in X than Y. So that one is always true. So I'm going to put my tick there. Question 15. Simplify fully a cubed b squared over cd times c over ab to the power of 5. What fun. Okay. So when you multiply fractions together, you can multiply numerator times numerator, denominator times denominator. So I can combine these two numerators together into one supernumerator. That's going to be a cubed b squared c on the top. I can do the same thing to the bottom, can't I? CD times ab to the power of 5. That's going to give me a b to the power of 5 cd. Just rewriting those factors down in alphabetical order. Okay, now can we cancel anything here? Well, the c's cancel. They can go. My a there can cancel with one of the a's there. I've got a cubed, which is a times a times a. So I can cancel one of the a's. That'll leave me with 2 more left, isn't it? A squared is left. Similarly, I can cancel these 2 b's here, b squared here, with 2 of the b's on the bottom. I've got 5 b's on the bottom currently, b to the power of 5. So if I cancel 2 of them, that will leave me with 3 left. Okay, so what's left then? I'm left with a squared, the b's are gone and the c's have gone on the top, and on the bottom the a's have gone. I'm left with b cubed and a d. So that's what we get. A squared over b cubed d. Question 16. Here are 2 sectors from different circles. We've got sector A, which has got an angle of x and a radius of 1.5 r, and we've got sector B, which has an angle of 2x and a radius of r. And we need to find out which sector has the biggest area. Now, the formula for the area of a sector is going to be the area of a circle, pi r squared, and then what fraction of a circle it is. So it's the angle at the center. We normally use theta for that, over 360. So you use the center angle to find what fraction of a circle you have, and then you multiply that by the area of a circle, and you'll get the area of a sector. Okay, so for sector A, that angle at the center is x, so I'm going to get x over 360. Okay, so this one is going to be x over 360 times pi r squared, but in this case my radius is 1.5 r, isn't it? So it's going to be pi times 1.5 r squared. Okay, and then in my other one I'm going to get a center angle of 2x there, so that's going to be 2x over 360 times pi times r. It's just r in this case, isn't it? R squared. Okay, now we want to work out which one is bigger. So I think probably the easiest thing to do is express them as a ratio then, and see if we can cancel bits off either side and see what we're left with. Okay, so I'm going to write these down as a ratio. So I'm going to do the ratio of sector A to sector B. So we just said that sector A is x over 360 times pi, and we had 1.5 r all squared. What's 1.5 squared? 1.5 squared is 2.25. So I'm going to say that's times 2.25 r squared. And then the ratio of that to the other one, which was 2x over 360 times pi times r squared. Now the reason I wrote this down as a ratio, it means that anything on the left that is the same as anything on the right, I can just cancel each other out. It's like cancelling down a ratio, isn't it? Simplifying your ratio down. So let's look through on the left and see what's the same as what's on the right. Now on the left I've got an x, on the right I've got an x. On the left I've got 360, on the right I've got 360. On the left I've got a pi, on the right I've got a pi. On the left I've got an r squared, on the right I've got an r squared. Okay, so just cancelling off everything that is the same will leave me with anything that is different. So what is left? So on the left hand side pretty much everything is gone apart from 2.25. On the right everything is gone apart from the 2. Okay, so that tells me that sector A to sector B is in a ratio of 2.25 to 2. Okay, so I can answer the question now. Which one is bigger? A is bigger. It's got a bigger ratio, isn't it? It's the bigger half of the ratio. So there is more area in sector A than there is in B. Okay. Question 17. A factory makes kettles. 4 samples of kettles are tested for faults. Each sample has a size of 200. Here are the relative frequencies of faulty kettles in the samples. So we had samples P, Q, R, and S, and they've got varying relative frequencies of faults. So we need to work out the range of number of faults of kettles in the 4 samples. Okay. Now if you remember in the question, it said that each size of each sample was 200. So there are 200 there, there are 200 there, there are 200 there, there are 200 there. Okay, so relative frequency would have been successful trials over total trials. So relative frequency is successful trials over total trials. Okay, now we've been given the relative frequency and we've been given the total trials. So I want to work out the successful trials. In this case, success is, in the crazy world of maths, a faulty kettle. So I can do that by cross multiplying. So taking this total trials and moving up here. In other words, multiplying the relative frequency by the total trials will tell me how many dodgy kettles there were in each sample. Okay, so first up, sample P had a relative frequency of 0.3. So for sample P, I'm going to write all this down because if I type it in my calculator, I need to write it down. So in sample P, 40 kettles equals 200 times 0.3, which comes out to be 200 times 0.3 comes out to be 60 kettles. Okay, in sample Q, that would be 200 times 0.035, which is 200 times 0.035 comes out to be 7 kettles. For R, we've got 200 times 0.015 comes out to 3 kettles. And then I've got sample S, which had 200 times 0.01 comes out to be 2 kettles. I just noticed I made a mistake up there. That should be 0.03. I thought 60 looked quite large compared to the others. 200 times 0.03 is going to be 6, isn't it? So it's 6, 7, 3, and 2. So then the range then, I need to find the range, don't I? So range is highest minus lowest. So range is going to be highest occurring, which was 7, subtract lowest occurring, which is 2. That's going to give me a range of 5. Question 18a. Write x multiplied by 3x minus 9 equals 4 in the form of ax squared plus bx plus c is equal to 0, where a, b, and c are integers. Okay, so let's start by multiplying out the brackets. So x times 3x is going to give me 3x squared. X times negative 9 is going to give me negative 9x, and that's equal to 4. So then subtracting 4 from both sides, that's going to leave me with 3x squared minus 9x minus 4 is equal to 0 as required. And part B says solve x plus 3x, x times 3x minus 9 is equal to 4, and give your answers to 2 decimal places. Well, we're going to use our rearrangement from part A, aren't we? So I'm just going to rewrite down what we just had. So we've got 3x squared minus 9x minus 4 is equal to 0. Okay, now give me the answer to 2 decimal places. That's a really big hint to tell me that I'm going to be using the quadratic formula here. So I just need to extract my coefficients here for a, b, and c. A is the coefficient of x squared, it's going to be 3. B is the coefficient of x, it's going to be minus 9. And c is my constant on the end, which is negative 4. Okay, once I know a, b, and c, I can sub those into the quadratic formula, which tells me that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's sub in our values of a, b, and c into that. So I've got minus b minus negative 9 is plus or minus the square of negative 9 minus 4 times a, which is 3, times c, which is minus 4. Now I always sub in brackets. I just think it helps dealing with all the negatives and things that come out of these things. All over 2a, which is 3. Okay, and let's see if we can tidy this up. Negative minus negative 9, that is going to be positive 9, isn't it? So that negative is going to make a plus. 9 plus or minus, what's the root there then? So minus 9 squared, negative 9 squared, negative 9 times negative 9 is positive 81. And I've got minus 4 times 3 times negative 4. And again, my 2 negatives there are going to make a positive, so it's going to become a plus. 4 times 3 is 12. 12 times 4 is 48, isn't it? So it's 81 plus 48 all over 2 lots of 3, all over 6. Okay, so what's 81 plus 48? It's 129, isn't it? So that is equal to 9 plus or minus root over 128 all over 6. Okay, almost there. So I'm going to get one solution when I add the root 128, and I'm going to get the second solution when I subtract it. So let's put the add one in first. I can just type it in now to the calculator in the form that it's in. 9 plus root 128 all divided by 6. That would tell me one of my values of x. I make that 3.3856, which I'm going to round up to 3.39. So 3.39. That's one of my values. The second value I'm going to get, instead of adding, I'm going to subtract. So I'm just going to press the back button so I can go back to the previous calculation. I'll go through and change that plus to a minus and press enter again. That's going to give me a second solution of x equals negative 0.39 rounded off. Okay, that's my second solution. All done. Question 19. Here is some information about the times people took to complete a survey. Fastest time 3 minutes, slower time 18 minutes, median is 11, lower quartile is 7 minutes, and the interquartile range is 8 minutes. Ben draws this box plot to show the information, and we've been asked to make 2 criticisms of the box plot. Okay, let's just go through and check the information then the fastest time is 3 minutes. Okay, so is that correct down at the bottom end of my line? So from here to here, look, we've got 5 units and it spans 10 little squares. So I make that 2 little squares for 1 unit then. So let's just work out the scale then. So 2 units is 1, that'd be 1, 2, 3, 4, 5, like that, wouldn't it? So he's got the lower end or the lower whisker of the box plot down at 3, so that one looks correct. Slowest time 18. Again, if I just mark those increments on, so that'd be 16, 17, 18, 19. The slowest time is correctly marked. Median 11. So 11, 12, 13, 14. Okay, so I can see he's made a mistake here. He's drawn the line 1 box up from 10, hasn't he? Which is actually 10.5 on this scale. So that's going to be my first criticism then. Median is marked at 10.5 and not 11. Okay, so that one was wrong. Lower quartile at 7 minutes. Okay, so 5, 6, 7, 8, 9. Now that is correct. So that one's in the right place. Interquartile range is 8 minutes. So I can see my lower quartile is at 7 and my upper quartile is up here. Look, that's at 16. So 16 subtract 7 is 9 and not 8. So he's got the upper quartile in the wrong place. So that's going to be my second criticism. Interquartile range is shown as 16 minus 7, which is 9, and not 8. Question 20. D is directly proportional to the square of V. D is 6 and V is 20. Work out an equation connecting D and V. You should be very happy when you see a question like this. It's totally straightforward, and if you've learnt the skill, you should just be able to stroll through it to get the full marks for this question. D is directly proportional to the square of V. So we write that down as D little fishy square of V, D little fishy V squared. D is directly proportional to the square of V. Okay, so that's step 1. Step 2, replace little fishy with equals K. D equals K lots of V squared. Okay, then step 3, use given pair of values to work out K. Okay, so when D equals 6, they always give you a pair of values that go together, and the reason they do that is so you can work out the constant. So when D is 6, V is 20, so subbing that in, 6 is equal to K lots of 20 squared. Now 20 squared is 400, so cross multiplying that, that tells me that K is equal to 6 over 400, which I suppose I can cancel down by dividing both by 2, which is 3 over 200, isn't it? I'm just going to leave it like that as a fraction. So what is the equation connecting D and V? Therefore, D is equal to 3V squared over 200. Okay, just subbing my value of K back into here, look. And then that's my complete equation. Easy squeezy. Right, what's next? Work out the value of D when V is 30. Okay, and this is again very, very typical of these sorts of questions. Once you derive your equation, you can then go on to use it to find other values. So when V is 30, then D is just going to have to sub that in, aren't I? So D is equal to 3 lots of 30 squared over 200. Okay, so just tap that into the calculator. 3 times 30 squared all divided by 200. It comes out to be 13.5. D equals 13.5. Okay, job done. 5 very straightforward marks. Okay, if you've learnt this method of proportionality, then it's a very easy 5 marks, that one. Question 21. Hanif makes green paint by mixing blue paint and yellow paint in the ratio of blue to yellow of 7:3. He buys blue paint in 50-litre containers costing £225 each, and he buys yellow paint in 20-litre containers, each costing £80. He wants to sell the green paint in 5-litre tins and make a 40% profit on each tin. How much should he sell each tin for? Okay, so he's making blue to yellow in the ratio of 7:3. Okay. So this one is blue and this one is yellow up here. Now I think before we start looking at costings, we need to kind of work out how many pots of blue paint and yellow paint we need in order to make a certain amount of green paint. We want to work it out in a way that we aren't wasting any paint. So is it possible to find a multiple of 50 litres and 20 litres that gives me that ratio of 7:3? So blue paint comes in 50 litres. So I'm trying to think of a multiple of 7 and that's also a multiple of 50. So let's just multiply those together to start with. Let's say that I got 7 tins of 50 litre paint in blue. That would give me 7 times 50. That would give me 350 litres of blue paint. Okay. Now, if I had 350 litres of blue paint, I would have, how much yellow paint would I need to go with it? So I've multiplied that up by 50, didn't I? So if I do the same on the other side, I'm going to need 150 litres of yellow paint for every 350 litres of blue paint. But 150 is not a multiple of 20. So let's just double that up then. So let's say 700, so multiplying by 2. Let's say I need 700 litres of blue paint, and for that I need 300 litres of yellow paint. Now that is a multiple of 20, isn't it? So, and that is a multiple of 50. So 700 is a multiple of 50, 300 is a multiple of 20. So I can work out how many of each paint pots I need to buy now. So let's say, so if I want 700 litres of yellow paint, then how many pots of yellow paint we're talking about? We're talking about 14 tins, aren't we? So that's equals to 14 tins. Okay, and for that I would need 300 litres of yellow paint. And if that comes in 20 litre tins, 300 divided by 20 is 30. It's 15 tins then, isn't it? Okay, so 700 litres of blue paint was 14 tins, and 300 litres of yellow paint is 15 tins. Okay, so, and that will give me 1,000 litres altogether, won't it? Okay, 1,000 litres of yellow paint, because I'm going to add them together, so by volume I'm going to end up with 1,000 litres of this stuff. Okay, so let's do that then. That seems like a good plan. So cost of paint. So if I've got 14 tins of blue costing £225 a tin, so for the blue it's going to be 14 tins at £225, plus I need 15 tins of the yellow, which is at £80 a tin. What does that come out to be then? 14 14 times 225 plus 15 times 80. That's £4,350. £4,350. Okay, so the cost of that paint is going to be 4,350. Okay, so he wants to sell the green paint in 5-litre tins. Okay, so paint then, 700 litres and 300 litres gives us 1,000 litres. How many 5-litre tins can we fill? We can fill how many? I've got 1,000 litres of paints divided by 5, so that's going to be 200 tins of green paint. Okay, so that 200 tins of green paint cost 4,350 to make. So cost per tin of green paint equals, well, I've got £4,350 worth of paint and I've made 200 pots of paint out of it. So divide that by 200. Gives me £21.75 a tin. £21.75 per tin. Okay. Just note that I'm kind of doing these little sentence starters at the beginning. It just makes your maths much easier to follow. Now you want to make life easy for your examiner on these sorts of long questions. They have a mark scheme and they're looking for certain things in your work, and the easier you signpost your working for them, the more likely they're going to spot and give you and award you the marks for the things that you're doing. And also I think it helps when you're coming back to check your own work. There's nothing worse than trying to mark a whole page of just numbers. Really difficult to find the bits that you're looking for or to award the marks. So just a top tip, just kind of put these little sentence starters, just explaining what you're doing as you go down. Makes it a lot easier to follow for you yourself when you come to recheck it, and also for the examiner. Okay, so what have we got to? We've got the cost per tin of the green paint. So we have dealt with that, we've dealt with that, we've dealt with that, we've dealt with that. But the only thing we've got to do now is this bit at the end, make 40% profit on each tin. Okay, so we know the cost of each tin is £21.75. So if we want to make a profit of 40%, I need to selling price is going to be the cost price, £21.75. I want to do a percentage increase, don't I? I want to increase it by 40%. So 100% add 40% is 140%, as a multiplier is 1.4. So I'm going to multiply it by 1.4 to find the sell price then. So £21.75 times 1.4, that comes out to be £30.45. Okay, so he needs to sell his paint at £30.45 per tin in order to make that 40% profit. Question 22. We've been given a Venn diagram and we're told that the universal set is 29 students in the class. C is the set of students who own a cat, and D is the set of students who own a dog. We can see that we've got some cat owners, some dog owners, some cat and dog owners, and some not cat, not dog owners. Okay, so a student is chosen at random. Circle the probability that the student owns a cat or a dog, but not both. So a cat or a dog, but not both. So we're talking about a cat, this area, or a dog, this area, but not both. So not the bit in the middle. Okay. So remember earlier I was saying about or and in probability questions. Or normally in probability means add. So probability of C or D, but not both. So it's just going to be that 5 on the left plus my 7 on the right over how many we've got altogether? 29 in the universal set. So 5 plus 7 is 12, isn't it? So it's going to be 12 over 29. It's that one. Question 22b asks, a student who owns a dog is chosen at random. Circle the probability that the student also owns a cat. Okay, so what is the probability that the student owns a cat given that he owns a dog? So if you look at our Venn diagram here, we know that the student is already in this set here. So it's got to be one of these 8 plus 7, one of these 15 students. Okay, so what is the probability then that he also has a cat? Is those people there then, isn't it? So it's going to be those 8 students out of a total of 15 students. So the probability of cat given that they're a dog owner is 8 out of 15. It's that one. Question 23. Here is a sketch of curve y is equal to 2 to the power of x. And there it is, it's sketched. Now this is what we call an exponential curve, where your unknown x is the exponent or power. So we need to transform this. So we're told on the axis above, sketch the curve of y is equal to 3 to the power of x. So how's that going to change things? Well, something that's not going to change is the y-intercept. It's still going to go through this point here, because the value of x at that point there on the y-axis is 0, and 3 to the power of 0 is 1, just as 2 to the power of 0 is 1. So it's still going to go through that point there. If the base of the number 3 is bigger, it's going to get bigger quicker, isn't it? So we're expecting it to ramp up much quicker on this side of the line. What about on the other side of the line? 3 to a negative power, so you're going to have, for the negative powers, you're going to have 1 over 3 squared, cubed, and so on. That's going to get smaller quicker than 2 will. So as well as it being taller on that side of the graph, it's also going to be smaller on the other side. So we're going to end up with a graph that looks something like this. So it approaches 0 quicker on the left hand side of the graph and gets taller faster on the right hand side. So something a bit like that, hopefully a little bit less wobbly than my pen there. Question 24. The length of a diagonal of a cuboid is 20 centimeters. The diagonal makes an angle of 24 degrees with the base. The area of the base is 150 centimeters squared. Work out the volume of the cuboid. Okay, now do you remember what the formula for the volume of a cuboid is? Volume is just length times width times height, isn't it? So we've already been given the base of this cuboid. We're told that the base, this bit down here, has an area of 150 centimeters squared. So if this was length and this was width and this is the height, then actually we already know this bit of here, isn't it? That's the base. So that's the 150 that we've been given. So we just need to know the h then to work out the volume of this cuboid. And we can find that by looking at this triangle here. Now, I don't know if you noticed, but this angle up here is a right angle. So we know the angle down there is 24, plus we've already been given the length of its hypotenuse. We're told that the length of the diagonal was 20 centimeters. So that's 20 centimeters along there. So we just need to work out then the opposite side given the hypotenuse and the angle. Okay, so which trigonometric ratio is that then that talks about opposites and hypotenuse? Well, let's just write down our mnemonic SOHCAHTOA as a way of remembering the angles, or remembering the ratios. So which one has got opposite and hypotenuse in? It's this one here, isn't it? Sine. Okay, so let's just write the full calculation down then. So sine of an angle is equal to its opposite divided by its hypotenuse. Okay, so the opposite is the thing we want to find, that's h. The hypotenuse we said was 20, and the angle is 24. So sine 24 is equal to h over 20. Let's just cross multiply that up there. And that tells us that h is 20 sine 24, which on my calculator, 20 sine 24 comes out to 8.13. So that's equal to 8.13. So then the volume is going to be 150, the base of my cuboid, times its height, 8.13. So I'm just going to multiply that through by 150. And that's my answer, 1220.2. Just going to write that down as 1.220, I think. So 1220. Done. Question 25. ABCD is a square. A is at minus 2, 1, B is at 0, minus 1, C is at 2, 1, and D is at 0, 3. You can see all those 4 points have been plotted on the graph. And the question says, a single transformation of ABCD is such that B maps to D, D is mapped to B. A and C are invariant points. Okay, so A and C are unchanged. This one and this one, that's what invariant means. It means they don't change. And B and D switch places. Okay, so D becomes B, B becomes D. So what sort of transformation is that? I'm thinking it must be a reflection then in the line AC, is it not? So the mirror line would be along there, look. So A and C would lie on the mirror line, so they wouldn't move when you reflect it, and then B would reflect onto D, and D would reflect back onto B. Okay, so I need to describe that then fully. When you're describing a reflection, you need to talk about the mirror line. That's all you really need to say. So what is the mirror line? It's a horizontal line, so it's a parallel to the x-axis, and it's passing through this point here, isn't it? Y is equal to 1. So the equation of this line is y is equal to 1. Okay, so we're just going to write that down now. So it's a reflection in the line y is equal to 1. Okay. Now 25b says that a different single transformation of ABCD is such that B maps to D, D maps to B. The only invariant point is 0, 1. Describe fully the transformation. So we're getting the same situation that these 2 points here are going to swap around, but the only invariant point is, what was it, 0, 1? The only invariant point is that point there. So how can that happen? Well, that can happen if the shape rotates, can't it? So if it rotates around so that B, so that B rotates around to the top and D rotates around to the bottom, then C rotates around to A and A rotates around to C, then the only point that doesn't move will be this point here, because it's the center of rotation then, isn't it? So the shape will have rotated around that point 180 degrees, sort of kind of a half turn. Okay, so that's how we're going to describe that one then. So describe fully the transformation. It's going to be a rotation. You need to say how far of 180 degrees. Normally you write clockwise or anti-clockwise, but with 180 it doesn't really matter which way around you go. You end in the same place, so you don't need to bother. but you do need to say where the center of rotation is. So center of rotation 0, 1. Okay, and that's what will get you the 3 marks. Get 1 for rotation, 1 for 180 degrees, and 1 for naming the center of rotation. Question 26. We're given 2 functions. G of x, we are told, is equal to 16 minus x, and h of x is equal to x cubed. And we're asked to solve g h of x is equal to 24. Okay, so this is a compound function, isn't it? And the way it works is you have to kind of work from the inside outwards. So we're going to start with x cubed, and then we're going to sub it into g of x. We need to take this equation here for h of x and put it in where the x appears in g of x. So we're going to take our value of x, we're going to cube it, and then we're going to take it away from 16. That's basically what's going to happen, isn't it? So let's do that then. Let's just sub that in. So g h of x then is going to be 16 minus x cubed. Now we're told that that is equal to 24. So what value of x makes that true? Well, I think probably the easiest thing is if I take that x cubed and move it to that side, that will make it positive. And we can take this 24 and move it to this side. And we're going to get 16 minus 24 is equal to x cubed. So 16 minus 24 is 8. Well, it's minus 8, isn't it? And that's equal to x cubed. So then we need to cube root minus 8 to find x. Cube root of minus 8, negative 2. Question 27. In this question, all lengths are in centimeters. A is a point on a circle center O. B is a point on a different circle center O. And AB, we are told, is 20. Okay, so here's the diagram. So they haven't marked that 20, have they? AB. That's this line here, isn't it? So we're told that that's equal to 20. Okay, now we're told that the equation of the larger circle is x squared plus y squared equals 144, and the radius of the smaller circle to the radius of the larger circle is in the ratio of 4 to 5. Okay, what's the question? Still not seen the question. Oh, here it is on the other side. Work out the size of angle AOB. So that's what we need to do. Work out the angle AOB. So AOB, so we're talking about this angle here, aren't we? That's the angle that we want. Let's call it theta for now. What is that angle? Okay. Well, we don't know, do we? Let's have a look at the information we've got down here. We've been given the equation of the larger circle. X squared plus y squared equals 144. Now, the equation of any circle centered on the origin is of the form x squared plus y squared equals r squared. In other words, the radius squared of this circle then is going to be equal to 144, meaning that the radius is going to be the root of 144, which is 12, isn't it? So that means that this distance here, O to B, is 12. Okay? We know the radius of the smaller circle to the radius of the larger circle is in the ratio of 4 to 5. So 4 to 5. If we know that the radius of the larger circle then is 12, what is the radius of the smaller circle? Using the unitary method, going via 1. So if I take 5 and I divide it by 5, I'll get 1. If I then times it by 12, I get 12. So if I do that to the other side, 4 divided by 5 and then times by 12, I should get my radius then of the smaller circle. So that is going to be 4 divided by 5 times by 12. That's 9.6. So then the radius of the smaller circle then is 9.6 centimeters. So coming back to my diagram, that's this side here, isn't it? So that's 9.6. Okay, so I've got a non-right angle triangle. I know all 3 sides and I want to find the angle. Do you know what to do there? It's the cosine rule, isn't it? So we're going to be using the cosine rule here. So in the cosine rule it says, well, let's just write down the cosine rule and then see where we are. So the cosine rule says a squared equals b squared plus c squared. It starts off a little bit like the Pythagoras theorem, minus 2bc cos a. That's the general form of it, isn't it? Okay, so here, so if you know the 3 sides and you want the angle, you need to make cos a the subject of this. So I'm going to rearrange it. So I'm going to make cos a the subject. So taking this bit and added it to the other side, or added it to both sides, and then subtracting a squared so it appears on the other side, I'm going to get 2bc cos a equals b squared plus c squared minus a squared. And then dividing both sides by 2bc, I'm going to get cos a equals b squared plus c squared minus a squared all over 2bc. Okay? Now, when you're using the cosine rule and you're labeling up sides, you label opposite sides to using the same letter as their angle. So from my diagram here, if I said that was, I said theta earlier, if I make it A, then this must be side A here. It doesn't really matter about the other 2. So that could be B and that could be C. Okay, so but A has to be the 20. The other 2 doesn't really matter. So let's sub those in then. So we're going to put in A is 20, B is 9.6, C is 12. So A is 20, B is 9.6, C is 12. We're going to sub that into this formula and then work it out. So that's going to be equal to B squared, 9.6 squared, plus C squared, 12 squared, minus A squared, 20 squared, all divided by 2 times 9.6 times 12. Okay. So what's that? We can put all that into the calculator, can't we? So 9.6 squared plus 12 squared minus 20 squared divided by 2 times 9.6 times 12. Now that comes out to be a negative number, minus 0.7111. Lots of ones. I'm just going to write down the first couple. But it's a cosine, so we want A, don't we? So we want to find the inverse cosine of that, then, don't we? So A is going to be the inverse cosine of minus 0.711. What's that then? So shift cos answer. Now that comes out to be 135.3 degrees. Question 28. Leo runs for 12 seconds. The graph shows his speed. So up the side we've got speed in meters per second, and along the bottom we've got time. So this is a speed time graph. Show that the distance he runs is less than 67.5 meters. Now, distance traveled is the same thing as the area under a speed time graph. So we need to find this area here. Now, it's made up of it's a complex shape, but it's made up of some easier shapes. If I get my ruler out, I can take this odd shape and I can divide it up into a triangle and a trapezium. About this last shape here, it's got a curved edge. I'm going to estimate this last bit. I think that's why it's asking me to say that it's less than something. I'm going to draw a line from there to there. And I'm going to say that this last section is a little bit less than this triangle here. Okay? So I've got 3 parts. I've got this part, 1, 2, and 3. Okay? I need to find the area of these 3 shapes and then add it together, and then that will be my estimate for the distance travelled. So area 1. Now that's a triangle, so it's half base times height, isn't it? So the baseline runs from 0 to 5, so a half, a half of 5, and then the height goes from 0 up to 8, so half times 5 times 8. Half of 8 is 4, 5 fours is 20, so that has an area of 20. Second section, area 2. Now that is a trapezium. So the formula for the area of a trapezium is half a plus b times h, where a and b are the 2 parallel sides and h is the distance between them. So my a value then is from here to here, isn't it? It's got so a is 8, b is 9, and then the distance between them is 4 then, isn't it? Okay, so that's going to be half of 8 plus 9 times 4. That comes out to be half of 4 is 2, 8 plus 9 is 17 times 2 is 34. And then finally I've got area 3. Now area 3 is going to be slightly less than the triangle I've drawn, isn't it? Which has got a height of 9 and a base of 3. So we can say that area 3 is going to be less than half base height, which is half times 9 times 3. So 9 threes are 9, 18, 27 divided by 2 is what, 13.5. So area 3 is just slightly less than 13.5. Okay, so then the combined area is going to be slightly less than, of those 3 things added together, 20 plus 34 plus 13.5, which is, just double check, I think it should be what they asked us it to be, so 67.5. Okay, which is what we were asking for, wasn't it? Yeah, less than 67.5, so we're done. So that's all, we've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.